Let's go to the next slide. Now we going to see about the epicyclic gear train velocity ratio of epicyclic gear train. There are two methods of finding the velocity ratio of epicyclic gear train. First thing is the tabular method, second thing is the algebraic method. First we are going to see about what is meant by tabular method. Here is the table to follow the velocity ratio of the epicyclic gear train. Here 4 steps can be followed to find the velocity of the epicyclic gear train. Here the step 1 can be the first thing is the arm can be fixed. The gear A can rotate through plus 1 revolution if the 1 revolution is anti-clockwise. If the arm C is fixed, say arm C is fixed, so it became 0. The gear A is rotate in plus 1 revolution. It will be the 1 revolution can be anti-clockwise. Here the gear B is it's a ratio of number of teeth is number of teeth on A divided by number of teeth on B, TA by TB, and also the arm is fixed. The gear A is rotated through the X plus X revolution. That means arm C is fixed. The gear A is rotated plus X revolution. So the gear B can be minus X into TA divided by TB. And third step is the add plus Y revolution of the all elements. That means the arm C also revolved plus Y direction, rotation plus Y direction, as well as the gear A can also be a plus Y direction. So B can also be a plus Y directions. So fourth thing is the total motion is the arm C is plus Y, then arm A is X plus Y. Here arm gear B can gear A X plus Y, and then gear B is Y minus here Y minus X into TA divided by TB. Here Y then minus X into TA divided by TB. This is the tabular method to follow them to find the velocity ratio of the epicyclic gear train. Okay, now detailed we see about the tabular method. First of all, let us suppose the arm is fixed. Okay, therefore the axis of both gears also fixed related to each other. Okay, and then when the gear A makes 1 revolution, okay, when arm is fixed, therefore the axis of both gears are also fixed related to each other. When the gear A makes 1 revolution in anti-clockwise direction, the gear will be make TA divided by TB. That means it's a ratio between TA and TB, revolution in clockwise. Okay, the gear A can be revolved in anti-clockwise, means it will be can be makes revolution in clockwise direction. Okay, here ratio between number of speed of the gear B and speed of the gear A equal to number of teeth on gear A. It's a ratio of number of teeth on gear A and number of teeth on gear B. Since NDA getting 1 revolution means speed in RPM, therefore gear A can be rotated on 1 revolution, so it will be NB equal to TA divided by TB. Assuming the anti-clockwise rotation as positive. Okay, here see the some anti-clockwise rotation as a positive, the clockwise is as a negative. We may say that when gear A makes plus 1 revolution, then the gear B will make minus TA, ratio between number of teeth on gear A and the number of teeth on gear B. Okay, revolutions, that means minus TA divided by TB revolutions. The second row of the table, that means here second row of table is secondly, if gear A makes X plus X revolution, then the gear B will be makes minus X into, that means the gear A in clockwise means it will be anti-clockwise, the gear B will be anti-clockwise. So because that minus x into Ta divided by Tb revolutions, the statement is entered in the second row of the table. In other words, the multiply each motions entered in the first row by x. Okay, in other words, the first row is multiplied by it's also simply called as this is the first row. For second row, for getting the second row is multiplied by x with the first row. Here 1 plus 1 into x means x, here minus x into Ta divided by Tb. Okay, in third row of the table, thirdly, each element of epicyclic train is given in y revolution and they entered in the third row. Okay, that means each elements can be getting in y revolution, so entered in the third row. Fourth row of the table, the motion of each element of the gear train is added upon the entered in the fourth row. Okay, the motion of each element of the gear train is added upon the entered in fourth row. Okay, we are going to next slide is the method, algebraic method to find the velocity ratio of the epicyclic gear train. This is the method of motion of each element of epicyclic train relative to arms is set down into the form of equation. It will be found in the form of equation. The number of equations depends upon the number of elements in the gear trains. Okay, the number of equations depends upon the number of elements in the gear trains. The two conditions are usually supplied in the epicyclic gear train. First thing is that some elements is fixed. Second thing is the other has been specified motion. Okay, there are two conditions. Two conditions are sufficient to solve the equation. Okay, here two conditions is followed in algebraic method. Some elements is fixed. Second one is the other has been specified motion. Okay. In this algebraic method, the speed of the gear A relative to arm C equal to Na minus Nc. The speed of the gear B relative to arm C is Nb minus Nc. Since gear A and gear B meshing directly, therefore there will be revolve in opposite direction. Okay, if gear A and gear B the meshing with directly means it will be getting the opposite direction. So Nb minus Nc divided by Na minus Nc equal to minus Ta divided by Tb. Let's arm C can be fixed in epicyclic gear train, therefore its speed Nc equal to 0. So it will be getting this equation Nb divided by Na equal to minus Ta divided by Tb. If the gear A is fixed, the Na is the okay. If the arm is fixed, if the let's arm is fixed, so Nc equal to 0. If the gear A is fixed, here Na equal to 0. So you are getting the equation as Nb minus Nc divided by minus Nc equal to minus Ta by Tb. It will be simplified like that. Nb minus Nc equal to 1 plus Ta divided by Tb. Okay. Now see one example of the epicyclic gear train. Okay. In this epicyclic gear train, the arm carried two gears. Okay, one arm's carrying the two gears. That one is A and gear B having a 36 and 45 teeth respectively. If condition 1, if the arm rotates at 150 rpm in the anti-clockwise direction about the center of the gear A, which is fixed, and determine the speed of the gear B. Now condition 2 is if the gear A is instead of being fixed. Okay, because of arm here gear A is instead of fixed being fixed makes 300 rpm in the clockwise direction. What will be the speed of the gear B? Now we are going to see this is the gear A. This is the arm C, this is the gear B. It will be directly meshed with gear A and B is the arm. Given is, that means number of teeth for gear A is 36, number of teeth for gear B is 45. The speed of the arm is 150 rpm in anti-clockwise, that means anti-clockwise. This is the table for followed to finding the velocity of the epicyclic gear train. A number of steps, 4 steps of can be followed to find the velocity ratio. Here, condition for motion: arm. First thing is the arm is fixed. The gear A is rotate through +1 revolution. If the one revolution is anti-clockwise, the arm can be fixed, so it will be 0. The gear A can be +1 revolution on +1, so the gear B will be counterclockwise, TA divided by TB, ratio between TA divided by TB. The second term is the arm is fixed, and the gear A can be rotated in +x revolution. The arm can be fixed, so it will be, that means first row can be multiplied by x. 0 into x, it will be 0. 1 into x, x here, minus x into minus ta by tb into x equal to minus x into ta by tb. And then third row is add plus y direction to all element. So arm C, gear A and gear B, it will be plus y direction revolution. The total motion is here, add the total motions. So plus x, here the x plus here x plus y, and also here y minus x into ta divided by tb. This is the total motion. Okay, I'm going to solve first condition. The speed of the gear B when gear A is fixed. When gear A is fixed, what is the speed of the gear B? The speed of the arm is 150 rpm in anti-clockwise. That means NC equal to 150 rpm. So y equal to 150 rpm. So also the gear A is fixed, therefore x plus y equal to 0. Here simplify this equation, x equal to minus y. So that y value is substituted here. So x equal to minus 50 rpm. The speed of the gear B is NB equal to y minus x. Here see the table. So y minus x into ta divided by tb. Here this y equal to minus x into ta divided by tb. Substitute the all values of here. Y value is 50 and also x value is minus 50. The minus and minus getting plus, and also TAB, the number of teeth on gear A is 36, number of teeth on gear B is 45. Simplify this equation, we will get the speed of the gear B will 270 rpm, revolution per minute. Okay. Now we are going to see the second step, the speed of the gear B when the gear A is maximum on 300 rpm. When the gear A is rotated at 300 rpm in clockwise, what will be the speed of the gear B? So we are going to, since the gear A makes 300 rpm in clockwise direction, here x plus y equal to minus 300. Okay, so x equal to minus 300. Okay, y value is here, y value is 150, so it will be get 550 or 510 rpm. So minus 300 minus 150 equal to minus 450 rpm. The speed of the gear B NB equal to y minus minus x into ta divided by tb. Let's y value is 150 minus x value is minus getting minus into minus getting plus 450 into teeth value 36 divided by 45. It will be get 510 rpm in anti-clockwise direction. Okay. Okay, this method for solving the epicyclic gear train. Thank you.